One thing before we get started, because I do get messages all the time, so I'll just put it out there so everybody knows. We're probably about 2 weeks away. The new grounding and bonding publication will be done. That particular publication will include NFPA 780, which deals with uh, the lightning protection for buildings and structures based on NFPA 780, and then we'll also have that particular portion as a separate book. So
Nice.
you can buy lightning protection separate if you want to. And I'm taking right now and I'm putting the publication, or I'm sorry, the presentation that'll be sent over, that will be added with it, and that's when you purchase one of the publications in hard copy that they'll give you the presentation. And we're in the process right now. We're updating everything to 2023. All the illustrations have been done to the generator, transformer, motor, compressor. We're going in, checking the sections, updating those because they were done based on the 2017, and we've already added the few extra that went in those publications. And you'll have the Journeyman and Masters, and then we'll also have all the calculation, different chapters that are going to be coming out too, with all the new sections, tables, and everything. So here, probably about end of July, I'm hoping August, somewhere in there, they'll be coming out periodically, one book at a time. But you'll have the Journeyman, you'll have the Masters, you'll have the electrical grounding and bonding 780, and all the calculation chapters. So all in all, you're probably going to be looking 27, 37, 38, 39, 40. You're looking at about 41 items that'll be coming out for sale, and they all will come with a presentation if you buy the copy. But in order to get the presentation, they'll have a thing set up where you submit to show that you are an instructor for whoever you're an instructor for before
Nice.
they'll give it. And those presentations will be in a PDF. So you're
Yeah.
getting a little extra something for nothing.
Well, coming
Yep.
soon, John Reeds.
Yep.
But the one thing I wanted to say is we did do a myth of the week about the grounds in the caisson grounds, the concrete encased electrode grounds in the caissons. And so that was really cool that you were able to bring up that NFPA 780 because that really added a lot of clarity to that, why they do that and stuff.
Sure. And, that's one reason we did the 780. And I will tell you that the new illustrations that are in 780, because every one of them will redrawn because it's just, it's a different animal the way you have to really structure it. And I'm
Mhm.
just telling you, they look freaking fantastic. So,
I 100% agree.
all right, let's get started on this and get everybody going on the full calculations here. These are based on the example problems that are in the Journeyman publication and the Masters. So I have to pull some over from the Masters in order to do a complete finish up on all of this. And y'all remember when we went over this when we were doing residential 2 weeks ago? On the top right hand corner up there, you're going to see that we have the bullet for sizing phases. For sizing the neutral, we'll have the check mark. And then when we do the total load, we're going to put the little star there for it. Okay. And the reason we do that, because in this particular one, we were doing before, we did 6 loads when we were doing the residential, and you could just put a bullet and a check mark beside it. But right here, we're going to be doing 7 loads, and this is where you're going to get in your lighting loads, your residential loads, your special appliance loads, your compressor loads. Then we get into our motor loads. Then we get into our largest between the heating and AC, and then we also do the largest motor load. And then we total all that up together. But the reason we do a total load on here, because like when you're doing your lighting, you can have the square footage. If it's a listed top occupancy, if it's not a listed, you got to do all the fixtures individually. You could have show window, track lighting, sign lighting, outside lighting. You want to take all of those once you calculate the loads and then add them up. And then that's why we got the little star on the side there because you would total that up for total load. All right. So one thing you're going to notice through the first couple of these is we're going to do the exact same type of loads. Okay. So all my 120 volt single phase loads will have a 100 foot a show window, but it's going to be non-continuous operation. We're going to have a 120 foot a lighting track. We're going to tell you it's non-continuous, and then we'll do 40, 180 volt VA ballasts that are outside. That's continuous. We have a 4200 VA sign. That's a continuous operation. Then we have 74 receptacles that are non-continuous, 24 that are continuous, and then a 100 foot of multi-outlet assembly that we're going to use simultaneously. All these loads will be the same for about, I'd say, for the next calculations. And then our 240 volt loads, we have a 12,000 VA water heater, a 60,000 VA heating unit, 24,800 VA AC unit, a 7,240 VA freezer, 6,480 VA ice cream box, 9,560 VA walk-in cooler, 1.5 horsepower exhaust fan, and one 2 horsepower water meter. Now, where this is really going to change is going to be up here, is going to be what type of service is supplying it.
Right.
Okay? That's where you're going to notice the difference. We'll still have a 50,000 square foot store with 30,000 square foot warehouse space, but you'll see one will say 120, 240 volt three phase system.
Right.
Okay? That means you're still going to be doing the same type of calculation. The only difference is how you determine your amperage. So I'm going to show you step by step. We're going to do exactly the same thing over and over, but we're going to do something different when we get over here and we're determining based on what type of service is supplying the service. Okay, now
Nice. Okay.
let's take a look here. Now, if you go over and you look at table 220.12, so give everybody a little second to get there because it seems like everybody always has a little bit of problem when they get into these. And let me rephrase, this is on 2020, by the way.
Gotcha.
So that's what we started on to start the year. And when you come down and you pick up your different things here for all your calculations and everything, and you do warehouse space and all of that, they're going to tell you here that when I come back and I look at this right up here, I'm picking up a store. Okay, so if I come over and I look at a store and come down, I'm going to be looking at the value I'm going to apply here, and it's going to tell you you got retail there, which is your store, and that'll be 1.9 VA. And then if I drop down just a little bit further and pick up warehouse, what does it say? 1.2. Okay, now these values changed when they started doing the energy code. The energy code, that's why these values are lower than what they used to be. Okay?
Okay.
So if I have a 50,000 square foot store, it tells me to take it at 1.9 VA. That gives me 95,000 VA. Okay?
Right.
Now, if I look at this, let's just say I looked at the store and I said the store was going to be continuous, what would I take it at?
1.25.
That's right. So I'm coming back here and I'm just sort of looking at this. I didn't give you anything here to tell you to take it up to 125% or anything. So we're going to keep this at 100% at this point. And the reason you're going to do that, because if you look down below that table, because I'm going to ask, and you read the note, it says 125% multiplier for continuous load is specified in 210.20A is included when using the unit loads in this table.
Right.
See that? So if you wonder why we didn't put the 125%, because there's a note below the table, and if you look at the 2020 code, you'll see that note was added here, and you'll see it's all shaded in the 2020 cycle. Okay.
Gotcha.
Now, the last cycle, we actually did it at 125%. Okay. So we just kept the same form here. We just did it at 100%. But if you'd have looked in 2017, we'd have had 125 there.
Right.
Okay. So people asking how we did it. So we took 50,000 square foot, 1.9 VA, 95,000. We put a check mark there for neutral load. Then I did it at 100%. That's going to be my phase load. So it's 95,000. Then I had 30,000 square foot of warehouse space at 1.2 VA, gives me 36,000 VA. There's my neutral load check. Then I take it at 100%. That gives me 36,000 again. Put my little bullet there. I'm good to go.
Nice.
Okay. Now, let's look at the next one. We got show window. Now, when I look at show window and I go over and I look at 220.14G and you pick up show window, it tells you in G2 there at 200 volt amps per linear foot of show window. Okay. So it's perplexing. Yeah, I agree with you, brother.
Yeah, one thing I want to just explain to David, and it's kind of funny because I'm working in Boulder right now, and Boulder's real big on energy, and so basically, the way these places look at this is we're gonna run out of energy someday, and so what they're trying to do is they're just trying to make it to where we just last the longest possible with the energy we have. So that was explained to me, David, and I thought that is an interesting point that we're gonna run out. We just don't want to run out as soon as
Sure.
keep as long as possible.
Now, if you look at that, also 220.43A, it says the same thing at 200 volt amps per linear foot shall be included for the show window. So, and when you go back here, you'll notice I didn't put 125% because we told you in this here that the show window was a non-continuous operation. Okay. So I take 100 foot at 200 VA. It gives me 20,000 VA. I'll put a little star here and a check mark here because those are going to be my phase and neutral load. Then when I look at my track lighting in 43B, it tells you an additional load of 150 volt amperes shall be included for every 2 foot of lighting track. So all that means is I'm going to divide the 2 foot into the 120 foot. That gives me 60, then multiply it by 150 VA. That gives me 9,000 VA. Now, look here. We told you the track lighting here, non-continuous. If that was continuous, even show window, I would have added 125% to this.
Right.
Okay. Now, let's look at outside lighting load. My outside lighting load, I come over, I pick this up. We told you we had a 180 VA ballast for my outside lighting load. We said it was continuous operation. So we'll take 40 times 180 VA. That gives me 7,200 VA. That's my neutral load. Then I'll take 7,200 times 125%. That's 9,000 VA. That's my phase load. Okay. And you may say, why are you doing these loads? Well, when you look over here and you're looking to be putting it under my neutral, because these are 120 volt single phase loads. Okay.
Right. So is that the only case where you don't have to do the neutral load if you have all 240 volt loads?
No, you do. You can have some 240 volt loads that have a neutral load.
Gotcha.
And we did that. Remember when we did the residential? I showed that.
Yes, sir.
Okay. Now the next one is sign load. Now, when you come over and pick up your sign load, we're telling you we have 4,200 VA of sign load here at continuous operation. Now, when you go over and look at 220.14F and then also look at 600.5A, those are the two main ones, it tells you the sign load has to be taken at least 1,200 VA. Okay. In this case, I'm above that, so I'll just take the 4,200, 100% is 4,200 VA for the neutral load. And then I'm going to get my sign load at continuous. So I'll just take it at 125%. That'll give me 5,250 VA. Then I'm going to take the 95,000, the 36,000, the 20,000, the 9,000, and another 9,000 VA load for the outside lighting. and 5,250 VA, and that's going to give me a total load for the phases here of 174,250 VA. Okay?
Gotcha.
Now, when I come back here, that takes care of the first load. That's calculating my lighting load. The second load I have is my receptacle load. Let's go back here and look at my receptacles. And you'll notice we did all these lightings, the first 4 here, 1, 2, 3, 4, and plus for the store and warehouse, that's 6. Then if you look, then I've got them right in order. 74 receptacles, 24 receptacles, and 100 foot of multi-outlet assembly here. Okay?
Gotcha.
Now, all I'm trying to do right here is show you how to categorize something when you're getting ready to do this calculation for testing purposes. Now, if I look at this, I said my non-continuous operation, I said I had 74 receptacles. Okay, so I'm going to take 74 times 180 VA. And if you go look at 220.14i, it talks about receptacle outlets, and they tell you take 180 volt amps for each one of those.
Unless you're in the residential, which we did a myth on that, how many receptacles can you install on a 15 amp circuit, which that was a pretty good one.
Yeah, well, you can go as many. It's based on doing it and what the minimum square footage is. And we'll go over that. We may do that as a myth again. I think that'd be a good one, and I'll go through and show everybody how to do that. All right. So you take 74 receptacles at 180 VA, gives me 13,320 VA. And then I'm going to look at my multi-outlet assembly. And if I look back at my multi-outlet assembly here, it's at 100 foot, but it's simultaneous use. So at simultaneous use, it just tells you take it at 180 VA. If I do non-simultaneous, that's a different calculation, but I'm not going to get into that since we're doing this. So I'll take 100 foot at 180 VA, gives me 18,000 VA. And then I total that load up. That should have been spaced over. I have to fix that. That'd be 31,320 VA. Now, you'll remember we talked about this as we were prepping before we got to these full calculations. And I said, when you do your receptacle load, if you're over 10,000, everything that's left after that, you can take it at 50%. But up to 10,000, you can take it at 100%. All right?
True.
So, and that's over in table 220.44. So I'm over 10,000, so I'll just put 10,000. What do I have left? I have 21,320 VA. I take that at 50%. That gives me 10,660 VA. Bring it over. That'll be my phase load and neutral load for those two loads. Then I have a continuous load. Take my continuous load here. I had 24 receptacles continuous. Take it at 180 VA. Gives me 4,320 VA. That's my neutral load. Then I take it at 125% for continuous. Gives me 5,400 VA. Add that 20,660 VA to that 5,400 VA, and that'll give you 26,060 VA for your phase load.
Yeah, one thing I want to do real quick, James, I just want to give a big shout out to all the apprentices out there who maybe think this doesn't make any sense, why we're doing all this math. But what we're trying to do is we're trying to figure out a demand. So a lot of the apprentices, like, they ask me, this is a question I hear a lot. They're like, hey, I have a panel that has 42 20 amp circuits in it. How can those all be on at the same time? Well, the reason why is because of this. We're calculating this demand of how much you're actually using in that panel. So not all of those 20 amp circuits are going to be loaded at 100%. So yeah, if they were loaded at 100%, you'd have 2,000 amps coming out of a 200 amp panel. But what we're able to do in with these calculations, this is the whole reason why this is important to learn, is because you can go in there and you can figure out, like, hey, this oven's not going to be on all the time. James isn't going to be plugging in his Dallas Cowboys live stream all the time. You know what I mean? So all this stuff isn't going to be, like, his Dallas Cowboys live stream's not even going to be continuous. It's only going to be for, like, 16 weeks out of the year, So we could factor that in and get like a smaller service, you know?
Sure. Uh, you know, eh, not everything's on at the same time at all
Yeah.
times. That
Yeah,
just doesn't happen.
like you're not gonna be watching the Broncos win and the Cowboys at the same time. You know what I mean? So it's just things you have to look into. You know, when you're doing your loading and your demand factor.
That's right. Now, let's look at this. Now, we're going to get in the next one. We're going to do our special appliance loads, compressor loads, motor loads, and then largest non coincident load, which is largest between the heating and AC. Now, when you look at this, I'm looking at these 240-volt loads here. Okay, heating and AC I can take off of here for my special appliance loads. Then I'm looking at my freezer, ice cream box, walk-in cooler. Those are all going to be compressor. Then I'm going to come over here and look at my exhaust fan and water pump. That's motors. So I'm looking here. The only thing I have here for special appliance is what? My water heater.
Yep.
Okay. So we're just sort of breaking this down so y'all see how easy it is. Don't overthink a lot of times what you're doing here. A lot of people get to overthinking things. And actually, it's pretty simple if you have it grouped out like this and you know if I'm doing a commercial calculation, I'm doing 7 loads. If I'm doing residential, I'm doing 6 different type loads. Okay.
So there's one thing I want to say too about that. With you make a really valid point with that overthinking, James. When I was taking my test, they're asking like, "Hey, how would you do step 2?" Like they're not asking you how you do all these steps. You know, so that's where it comes into a lot of overthinking because they'd be like, "Hey, how would you perform step 2 of this calculation?" So they're only asking you to do one little part. So that's all you focus on. So I think you make a good point on that overthinking. There was something where they were asking me a question about something about agricultural buildings, and I was like trying to do a calculation, and they weren't asking for that, you know. And I remember that on my test, and I was like, man, I can't believe I was trying to do a calculation, and it wasn't even a calculation. It was just asking me where I would go find it at. You know, so that's the thing when it comes to overthinking. It's about dissecting the question when you're in the exam and making sure that you understand what they're asking. And, you know, like if you don't understand what they're asking, just skip that one and go to the next one. You know,
Sure.
and then it'll make sense because but you remember this one that we did before where they said what type of wire is not permitted to be installed in a poultry plant. That was my first question on my journeyman exam. And I had no clue, you know. And I fought with it for like 10 minutes. And I shouldn't have. I should have just skipped it. I should have been like, I don't know where I'd find that in the code. Well, next thing you know, I'm in agricultural buildings. It says, these buildings are such type of buildings as poultry plants, and it's type NM, you know. Romex can't be ran in a poultry plant. I guess the chickens perch on it. Like they run and the chickens perch on it, and then and they get killed. Like kind of what you were talking about, cows. So a lot of that agricultural livestock stuff kind of drove the code, and you have to know that kind of why they put it in there. So
Sure.
not trying to interrupt. I'm just trying to say that you have to be able to dissect the question, find out what they're asking, what they want, what they're trying to ask if you know, and
Sure.
you know.
And that's what it comes down to, and that's why Dad and I've been doing this for a long time. And if you ever look at our publications, we've always grouped everything out to make it as easy as possible, and then we put everything in steps at that point so it's easier to understand. So if you look at the way that we had it at the first, we went through the lighting and receptacle, and then we do a receptacle, a special load. So here I had the water heater that was at 12,000 VA. I'm going to take it at 100%. That's going to give me my load here. There's no neutral load there. You're just going to see a bullet beside it and the star. So that's going to be my phase load. Then I'm going to look at calculating my compressor loads. I had a freezer load, an ice cream box, and a walk-in cooler, all of them at 100%. Now, the thing is here, we'll get in where you're dealing with motors and stuff here, but just remember, even though you're calculating all of these at 100%, when I get to the last step, calculating largest motor load, whichever one has the largest between all of these, I'll take it an additional 25%. So
True.
for my freezer load, I had 7,240 VA, take it at 100%. Same thing for my ice cream box, I had 6,480, and for my walk-in cooler, I had 9,560 VA.
Right.
Now, when you get over here and you look at your water pump, you're you'll see we're telling you 430.24, but the reason we're telling you that is because we have two or more motors. Okay.
Right.
And that ties me in also when we do our individual calculations on motors. I always tell you to look at 430.6A1, and it tells you anytime you're calculating your conductors or overcurrent devices to use one of the tables in 430.247 through 250. In this case, it's single phase. And when you come back here and look, let's look at my two motors. I have a half horsepower exhaust fan and a 2 horsepower water pump. Okay. So
Yeah.
I come over here and I look at my water pump. It was a 2 horsepower. I go over, pick up the 230 volt column and table 430.248 for single phase. Come down, it's going to tell you it's good for 12 amps. Then I do the exhaust fan, come down, it's going to tell you it's good for 4.9 amps. And then just to put it in VA form, it's take it at 240 volts, and that'll give me 2,880 VA for the water pump and 1,176 VA for the fan load. Add all that up together, gives you 4,056 VA. Now,
Nice.
now I've done every load pretty much at this point except for two. What is the largest between the heating and AC load? Well,
Yeah.
we can look over there, go back, but we can just tell by looking the heating load's the largest.
Yeah.
60,000 is larger than 24,800 VA. So
Yeah.
right there beside it, I'll put my little bullet and star there for 60,000 for my phase load here. Then I'm going to look up here. Let's look. My exhaust fan was 1,176 VA. My water pump was 2,880 VA. My walk-in cooler load was 9,560 VA. Ice cream box was 6,480 VA, and the freezer load was 7,240 VA. Looking
Yep.
at all those, my largest one was the walk-in cooler.
Yep.
So I'm going to take that an additional 25%, and that'll give me 2,390 VA. Okay.
Nice.
Now you've got all your loads there. All right. So I'm just going to come over here and calculate my phases. For the lighting load, I had 174,250 receptacles, 26,060 VA. Special loads was 12,000 VA. Compressor load was 23,280 VA. Motor loads were 4,056. The largest between the heating and AC is a non-coincident load was 60,000 VA, and the largest motor was 2,390 VA. Add them up, 302,036 VA. Then I go back here and just look right here. Here's my lighting load, add all those check marks up together. Here's my receptacle load, add those check marks together. Okay? So I come back over here. My lighting load was 171,400 VA. Receptacle load was 24,900 VA. Add that up, 196,380 VA. Then you just take each one of those amperages, divide them by 240 volts. And for the phase A and B, you'll get 1,258 amps. And for the neutral load, you had 818 amps. Okay. Now, when
Yeah.
you look at that, that's pretty easy to follow. Now,
Yeah.
look at this one. You'll notice all the loads are exactly the same. The only
Yep.
difference is I have a 120, 280 volt three phase service. And so that I still have all the same 120 volt loads, but for my three phase, they're 208 volts. So let's go
Right.
back and look at this. I don't have to spend much time on this.
It's slightly more
Exactly.
efficient. The thing that really I guess jumps out at me, and it's not saying that anything's wrong, but the lighting loads are so high on VA. Like to me, like you have like commercial buildings now that are just burning almost nothing. You know, I mean, to me, it's crazy. Like how much technology has advanced beyond the code. You
Oh,
know, I
sure.
mean,
These loads come down quite a bit. These are just normal loads that we used to see.
yeah,
And this is the type of stuff they will ask you. That's why we don't change it. Is because
uh
this
huh.
is the type of stuff they'll want to see if you know on the test or not.
I agree, 100%.
So, and when you're looking at this, here's the lighting load. None of it changed. It's exactly the same calculation. Come
Yep.
over here, the receptacle load, exactly the same calculation. Come over here, special load, pressure loads, exactly the same. But where does it change? Motor loads.
1.73.
Right here. Look at my motor loads, how they changed here. My largest motor didn't change here, but look at here. Now I'm doing it under what? 360 volts. It's three phase at this point. So when I'm looking at this motor at this time, instead of over here where I was looking 204 volts, 240 volts, where am I looking now? 208 volts. Okay. So
Right.
there is where your difference took place. So it's three phase. So what you're going to do is take that 208 volts times 1.732, and what is that going to give you? 360 volts. So
Yeah.
you would go over and you would pick up that 2 horsepower motor under what? The 208 volt come down. It's going to tell you it's good for what? 7.5 amps.
There
Then
you go.
multiply it at 360 volts is 2,700. And then my other one totals up to 2.4 amps at 360 volts. That gives you 864. This is the only thing that changed in that calculation right here.
Right.
I did not do anything different except for that. And then I divided all them loads added up at 360 volts at this point.
Yeah, and it is slightly more efficient. The 208 three phase.
Sure. And look at this. Here's a 277 volt, 480 volt. Now I still got all the same 120 volt loads here, but when I look at the lighting, we're telling you the office area and warehouse lighting is 277 volt right here. All these others are 120 volt loads. And then I'm going to look here. Everything over here is exactly the same, but we're doing 480 volt three phase. So when I come over here, look at here. The lighting load's the same. Come over here, I pick up the receptacle load's the same. Special appliance, compressors, and where did it change? Right here at the motor loads. Okay. Everything else stayed the exact same type calculation. The only thing that changed here was the motors because I had to go over and look in the 460 volt column, come down to get my amperage. In this case, for the 2 horsepower water pump load, that was 3.4 amps, and I multiply it by what? 831 volts because 480 volts times 1.732 gives you 831 volts.
Right.
That's the only thing that changed here. I didn't do anything else different. Okay. All I was looking at is where I got my loads from. Okay. But what I do want to point out in this one calculation here,
So is that supposed to be volt amps or volts? Because I don't know why it said 831 volts.
that's because it is volts. It's not
Okay.
volt amps.
Okay.
You're
Oh,
dividing it.
oh, oh, so that's your multiplier.
Yeah. Or
Okay.
that's what I'm dividing with.
Oh,
Not
gotcha.
multiplying. Now, I
Gotcha.
want to point something out. You could see this on the test. See where I said the office area and warehouse is 277 volt lighting? The
Yep.
reason we're telling you this is because this is what's going to be your neutral load here, because my neutral load here is what? 277.
Right.
These 120 volt loads, even though they're neutral loads, they're not calculated into the service. It has to be a 277 volt load. Now,
Gotcha.
I want to point this out because when you look here at the lighting load, notice none of these others have a check mark. Where do I have a check mark at? For the store and the warehouse space.
There you go.
Okay.
Because
So
that's continuous.
that's right. So I'd take the 95,000 plus 36,000 VA when I'm doing the load, and I'll give you a total neutral load here for the lighting of 131,000. I'm not adding those others in there. Okay, that's something you need to pay real close attention to on the test also.
Oh, there's somebody else paying real close attention. That's Mr. E. David Englehart.
That's correct. We did say that. Table 220.44. All right.
In the
Now,
2020.
now, this is a good one here because the other one we did was 12208. This is a 12240 volt three phase. The very first one we did was 12240 single phase. This is a three phase. Now, if you look, everything's still the same. I didn't change anything in the calculation. So here's my lighting load. You'll notice I have all the same check marks, the bullets, everything coming down total load. Same thing on the receptacle outlet. Come down, special loads, freezer loads, water pumps, exhaust fan. All of that is staying the same, except this one here, since it is a three-phase system, I have to multiply this by what? 416 volts, because I'm going to take the 240 volts time what? 1.732, just like I did the rest of them. But you'll notice everything else stayed the same, even up to the largest motor, which was the walk-in cooler. All right? Now, the only thing I want to find out here is this. I need to take and I need to calculate, because I need to calculate my B phase here, because I have a three-phase load here at 120, 240 volts. So I'm going to have some single-phase loads here and three-phase loads. Right. Okay? So let's see how I go about this. Well, for single-phase loads, I'm looking here. I have the lighting loads and I have the receptacle loads. Add those together gives you 200,000, 310 VA. Divide that by 240 volts. That gives you 835 amps. Right. Look at my three-phase loads. Add them all up. We had to do the motors at 416 volts. Mm-hmm. So I come down here, 101,414 VA. Divide that by 416 volts. That gives me 244 amps. And then I look at my neutral load here. I had my lighting loads and receptacle loads. That's 196,380 VA. Divide that by 240 volts. That gives me 818 amps.
There you go.
So now I'm just looking at what is my total load here. Well, I did my three-phase loads, which is what? 244 amps. And then if I looked at my single-phase loads, what was the total load on that? 835 amps. Multiply or add those together, and that'll give me a service here of 1,079 amps.
Right.
Okay.
And this is where it comes into the efficiency, because
right.
With your single phase, you'd be at 1,000, but you're dropping all the way down to 244.
Sure. Now, how many more of these I got? I just want to check to see what I got. I'm going to do one more, and I'm going to pick up on the next ones next week. Okay. It's getting late. There's so much going on here. All right.
Dude, now, I love the fact you're putting these together. Like, everyone gives me positive feedback all the time, telling me how much they like it, how much they learn and everything. So,
well,
it means a lot.
I hope they are, because we actually put a lot of time into this. There's a lot of work that goes into designing all these calculations and putting them in steps and all that. And we're not doing on this because it just takes too long, but I also have this where you can go in and fill in the blanks and work a full calculation. We actually have forms for this.
So we're gonna have to do a new segment to this topic for apprentices that are out there. If you want like questions on your homework, send me or James a question that you have on your homework, and we'll feature it and we'll explain it and go through it at the end of our topic. That's what we're gonna try to.
If y'all have any questions, just fire them at us. Let us know. I'll go through and answer all this.
We might not be able to answer them live, so that's why I'm saying it might be too tough. Like James is trying to produce all the material, and so it might be something better. You just contact us offline, either at Nat King Code or at Stallcup Electrical Education, And then what we'll do is we'll go through the questions, and then we'll just feature one every week and just answer it, and just answer it at the end of our topic of the week.
Right. Now, this one is exactly the same type of calculation. We're going to have a 277, 480 volt, three phase, four wire service, but it's going to be a little different because we're going to do an office space. Okay. We have 140,000 square foot of office. And if you go over and pick up table 220.12 and come across, it's going to tell you it's good at 1.3 VA. And then if you look at your warehouse, which we had already done, come down, pick it up, it's at 1.2. And then we tell you all the lighting for this is going to be at 277 volts. So if I look at my 120 volt loads, this won't go towards the neutral. We don't have to worry about the lighting track, the outside lighting ballast, or the sign here, or the isolation transformer for the LVLS. All right. All of
Right.
that right through there is 120 volt loads. So that's not going to be applied to the service. Now, one thing I want to point out, they may have you do something like this where you calculate these full loads, and you may be doing 277 volt loads, and by all you have is just applying what is in the table. Okay, because they're two. That's your lighting is 277 volts, and you may calculate it and come up with say 100 amps, let's say. But I want you to remember, if that happens and they want you to size the conductors for that, make sure you go over and look at 310.10G, because that's where you're going to pick up where you have conductors in parallel, because it's going to be a large service. And that neutral conductor would, instead of putting a number 3 there, you would at least have to put a 1-off conductor.
Right.
Okay. All right. Now, as I look at this, my 120 volt loads is 50 foot of lighting track non-continuous, 2080 VA ballast for my outside lighting. We're going to do that at continuous operation. A 4200 VA sign at continuous operation, 174 receptacles non-continuous, 114 receptacles continuous, a 6000 VA isolation transformer for your low voltage lighting system, that's continuous. And then we have 160 foot a multi-outlet assembly that'll be simultaneous use. Then I look at my 3-phase loads, and this is what you have in there for your office. We got copying machines, data processors, work processors, printers, and then I also have a water heater.
Nice.
Okay. And then what are my motor loads? Well, if I'm looking at this, do I see any compressor loads in here? I don't see compressor loads. Okay. But I do see a 40 horsepower elevator. This means I'm going to be looking over in 430.22E, because this is an intermittent duty, 15-minute interduty motor. And
Nice.
then I don't show AC here. I just say, we're just saying we have a 40 kW heating unit. All right.
Nice.
So here's my loads. All right. So let's go. Now I'm already looking at this. I always think I have to have 7 loads, but in this case, I'm saying I only need 6 loads, because I don't see what? Refrigeration compressors in here.
Yeah.
Okay. All right. Now let's take a look. Same thing we've been doing. We had our general lighting load. We said we had 140,000 square foot of office space, and I said go over and look at table 220.12. It'll tell you take it at 1.3 VA. That'll give me 182,000 VA. Now, as I've said before, there's a note below that table. The 125% is already taken there, so you just go ahead and put a bullet down below there. Then I had 2,500 square foot warehouse space here. That's 3,000 VA. Just bring it down. That's your neutral and your phase load. Then I
Nice.
looked at my track lighting load. I had 50 foot of track lighting. It says you have to take it every 2 foot, so I'm going to divide into that. That's going to give me 25, so I'll multiply that at 150 VA. That gives me 3,750 VA.
Right.
Then I'm going to come down, pick up my low voltage lighting. We said that was at 6,000 VA. We also said you had it at continuous use, take it at 125%, gives me 7,500 VA.
Nice.
Excuse me. Then I had my outside lighting load. We said we had 20 units there at 180 VA, gives me 3,600 VA. We said it was continuous, so we'll take it at 125%. That'll give me 4,500 VA. And then the sign load was 4,200 VA, which is more than the 1,200 VA, which is fine. Take it at 125%. That gives me 5,250 VA. So right here, I've got my neutral and my phase load. Then I want to total all my phase loads together here. That'll give me 206,000 VA.
Nice.
Then I'm going to look at receptacle loads here. Looking at my receptacle loads, I had 174 non-continuous receptacles. So I'll take that at 180 VA, gives me 31,200 VA. Then multi-outlet assembly, I had 160 foot of that. Take that at 180 VA. That gives me 28,800 VA. Now,
nice.
What I'm going to do here is I'm going to look, because if you go over and look at 220.14i and also look at table 220.12, you're going to see I have a 1 VA on there.
Yep.
Okay. And a lot of people don't ever look at this. So this is one where you've got to start understanding that this is actually a little more in depth of a calculation here and understanding what you need to do. Because when you look at the table here, it's going to tell you take this 140,000 square foot at 1 VA. And it's going to show you that this load here for the receptacle load for applying the demand here is going to be more than if I did these individually. So now you're going to look, instead of the load being 60,120 VA, actually that load is 1,000 VA.
Wow.
And that's why we go through this. And a lot of people don't know that that's in there. Matter of fact, I'll tell you this, I've never even seen anybody show this in their calculation.
Yeah. Oh, you know what you've never even seen either?
What's that?
Dun, 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 dun. Here comes Daniel J. coming in for the kill on the Willie quiz. Oh, he came out of nowhere. Welcome in, Daniel J.
I ain't worried. Okay, now our continuous receptacles, we had 114 of those. So we'll take that at 180 VA, gives me 20,520. Then it was continuous, so I take it at 125%. That'll give me 25,650. So I take the 140,000 plus 25,650, and that'll give me 165,650 VA. All right. Then look at your special loads here. I went through this and I said all of those were special loads, but you notice when I get the next one, there's no compressor load, is there?
Nope.
Okay. So I'm just going to take those special loads. I had a copying machine. I had 4 of them at 1,275 VA. That gives me 5,100 VA. I said they were continuous. That gives me 6,375 VA. You got a water heater. That was 8,000 VA. It's not continuous, of course. So I'll take that at 8,000. And then the remaining things here were all continuous. I had 22 units of data processing load at 225 VA. That gives me 4,950 VA. Take that at 125%, gives me 6,180 VA. So I've got my little bullet marks there. I've got my word processor load. There's 8 units there at 175 VA, gives me 1,400. Take that at 125%, gives me 1,750 VA. Put a star there. Then I had my printer load, 2 units of those at 1,000 VAs, 2,000. Take that at 125%, gives me 2,500. Add all those bullets up together, and your special appliance load is 24,813 VA. Now,
nice.
What I want to point out, if you notice what I've done through all these calculations, even when I did residential, there will only be one variable to this in the 2023 that we'll be adding to this next time is where we come in and we do electrical vehicle equipment. Other than
Yeah.
that, you want to remember this: I do lighting loads, receptacle loads, then I look at my refrigeration loads, motor loads, and heating and AC. Everything else that was left went where? In the special appliance. When I
Yeah.
was doing residential, it went into what we called the fixed appliance load. Okay?
Yeah. And then the EBSE will modify that for the 2023.
It'll just be another group
Yeah.
individually.
That's
So
not that's not connected to an outlet.
that's right. Yeah, we'll be getting into that in July as
Yeah.
everything comes out. All right, so we looked at our motor loads. We had a 40 horsepower motor, and I said, when you look at this, you need to look at 430.22E, which is going to refer you to that same section at the table. And it's going to tell you when I'm looking, let me go back here so everybody can see this so they remember. When you're looking at this motor here, right here on the 480 volt loads, you'll see a 40 horsepower elevator with a 15-minute intermittent duty here. Okay. So I'm going to go over and look at table 430.250. I'm going to pick up the 460 volt come down, pick up 40 horsepower. And when you pick up that 40 horsepower, it's going to tell you the amperage is 52 amps. Then I'm just going to multiply that 480 times 1.732 is going to give me 831 volts. And then when you go look at table 430.22E for that 15-minute intermittent duty, it's going to tell you to take it at 85%. So
Right.
you just multiply all that together, gives you 36,730 VA. Then my heating load, the only thing I had there was 40,000. And then, of course, we know looking at this, it's easy to know this. The 40 horsepower elevator is the largest motor. Take
Yeah.
that 36,730 VA at 25%, 183 VA, add everything up for the facility that's been totaled up, and that'll give you 482,376 VA. And then all you're going to do at that point is divide it by 831 volts, and that'll give you 580 amps of load. And then when you do your calculate neutral, just go grab all your check marks. Make sure when you're on paper, put a check there so you know which one's a neutral load. Then just add them all up, and then divide it by 831 volts, and that'll give you 268 amps.
Nice.
And that is where I'm going to stop tonight. That's a lot to cover.